Okay, great. Thank you for coming for the seminar on audio cables, interconnects, power snakes. My name is Cal Lidke. I'm a member of the Los Angeles Orange County Audiophile Society. It's a wonderful society to belong to if you're unfamiliar with it. It's the largest audiophile society in the world, and if you have questions about becoming a member, please see me right after the seminar. We have on our dais today talking about the different kinds of interconnects, 4 people who are legends. Certainly their companies are industry leaders, and the reason why I chose these gentlemen and their companies to represent this particular panel is because I've owned or am owning, using in my system, their product, and so I can speak from experience that what they are selling does make a difference in your system. And what I'd like to do today is kind of figure out why that's the case and how they go about doing it so all of you can benefit. So, in no particular order, but according to height, we have Ray Kimber, Joe Kubala, George Cardis, and Grant Samuelson. Please welcome them to our panel, please. Excellent. So I'd like to begin, gentlemen, and you can order in whatever turn you'd like to. Briefly explain your company's philosophy or approach to audiophile cable design and manufacture, and just tell us briefly, what is it that is in the music or in the sonic sound field that your company is chasing? Where do you want to start? Ray, first.
Okay, all right, okay. So first I think I should bring you up to date on a little bit of industry-related crime news. The Energizer Bunny has been arrested, charged with battery. Okay, anyway, so. Good. So,
they are awake, at least this
Yeah. At least that happened. Well, the design philosophy started from a reduction of both picked up and radiated noise, and so hence the counter-rotating braid, which doesn't act like an antenna. And then over the years, we got much more sophisticated about the conductors and the insulators that we used, and began to experiment with some different geometries, which let us control the difference between series induction and parallel capacitance, and then the number of conductors, of course, DC resistance. And so I would say that the primary reason that the company started at all was to prevent the pickup of nearby electrical and electrostatic noise.
Joe Kubala of Kubala Sazna. I guess for us, although the methods are different, the goals were quite the same, keeping noise out of the cable, if you will. And we started that originally with some geometry changes and then some shielding differences. And so if we had a basic philosophy, it would be keep the noise out. And if we had a basic goal, it would sort of be the Harry Pearson absolute sound kind of goal of it sounding like a real acoustical instrument in a live space.
Yeah, I've been in the cable business for one way or another for much longer than most of you suspect, but a long time ago I worked for the telephone company and built transmission lines amongst other things, but I ran across some musicians at some point who were selling their blood to pay for their music, and got kind of involved with them, and I came to the conclusion, I mean, I was sort of an audiophile at the time and had been into audio all of my life, but that something was getting lost in the process of reproducing the music. And the conclusion I came to was that cable was integral to that loss. And so here I am today.
Our company, Shunyata Research, is fronted by Kalen Gabriel. fronted by Kalen Gabriel. Kalen's a former National Security Agency scientist whose specialty was power supply design and dissipating noise in electrical and component systems used in the military to detect low-level signals. Kalen applied those skills in the music industry now. Our focus really is electrical systems, but in signal design, similar to what Ray said and Joe, it's all about the dissipation of noise and the electromagnetic interference and radio frequency interference that often systems are bathed in, and not necessarily coming from outside, but coming from the system itself. And this is especially true in electrical products, power cords and power conditioners. For many years, they're sold and marketed based on being able to create a better brick wall to block the noise coming in from the grid. But really, more and more, we're learning that it's the internally generated noise, the power supply generated noise by the electronics themselves that are all interconnected, that are all feeding off a common point for power, that really is the source of the losses that people often experience when they're listening to music and hearing what might be perceived as barriers to true resolution that you really only notice once those barriers are removed. So we focus a lot on internally generated noise. In signal cable, Kalen holds a patent for a circuit that's applied to either end of the cable that minimizes dielectric absorption, meaning less of the signal gets lost into the dielectric as the signal propagates down the wire. So I would say that's the defining signal cable technology.
That's great. Speaking of power cables, I bought an amplifier a few months ago costing thousands of dollars, and they were kind enough to give me this power cable to use in my system. And I'm just kind of wondering, is this adequate, or where have I gone wrong, or more specifically, how can you set me right in replacing this cable?
Okay, I'll start. But first of all, I just need to ask a question by a show of hands. How many people here play a stringed instrument, like violin or guitar or something? Okay, fine. That was it. The conductors may be okay. The male end may be okay. The bugaboo is the part that the female part, because the contacts, especially when you have a molded part, don't have enough contact area and can't squeeze the receptacle hard enough, because most of them, if you think of hold your hand up there for a second, because it's squeezing around this way, so you've got a couple of knife edge contacts, and it's really easy to displace that springiness. And that was actually the impetus for me to develop the Wattgate connectors. We were buying plugs from Marinco that were custom plated for us, and when I wanted an IEC, they said would never sell enough for them to cover the tooling cost, and so I came up with $100,000 to cover the tooling, and we built it as a 40 amp rated design for the original Wattgates, and we have sold more than they thought.
So the female end is the weak link.
I'm thinking back to the first articles I read in the mid-'80s maybe about power cords and the differences they might make to your equipment, and I thought, now how is that possible? I mean, the old miles and miles and then this much, and how can it make a difference? I can tell you when I first tried one, it was obvious why or how that it made a difference. Let's just put it that way. And so you're right about the conductors, except of course there might be things to gain by increasing the gauge. There might be things to gain by playing with the dielectric material and the geometry inside. And I can tell you that the sophistication of cables today offered in the power area, well, in any area, but we're talking power cables right now, by all of the manufacturers, have brought the performance of those cables to new levels. And they're one of the most impactful changes that you can can make to a piece of equipment.
Can you say briefly, what is it that your company is doing to make a difference in the power cable?
I guess the things we just talked about. We play with geometries, we play with dielectrics, we play with strand counts and total gauge and connectors, of course, yeah.
George?
I've been making power cables for about the same length as I've been making speaker cables, I suppose. Years ago, I had one of my customers call up and say that he'd taken one of my speaker cables and made a power cable out of it, and it made this huge difference. And it kind of shocked me. I didn't believe him, really. But so I went ahead and did it, and then I went, oh my God, like it does make a difference, you know. And at the time, I didn't know why. And as time went by, I realized that, when I started focusing on just that, there was a problem with noise on the line, specifically on the ground leg, but on the other two legs too. And that power filters in general weren't addressing it for some reason. And I think what was happening is that the ground leg on the input to all of your devices is center tapped to the transformer. And the transformers should take it out, in theory, on a piece of paper, but in reality the transformers aren't symmetrical to themselves, so the noise was passing through on the ground leg, and that was a fairly large portion of it. Well, as it happened, I was recording at the time, and I had a microphone preamplifier that was very sensitive to power cords, and you could flop between them in one thing or another, and you could actually see the noise floor change. I mean, quite noticeably. It wasn't, you could put it on a scope or listen to it or whatever you wanted. So that's how I worked out the first ones, and basically we bandwidth limit all three conductors in the power cord, and we do it by virtue of using differential length in the strands, and all the strands are individually insulated from each other, so you've got a differential path along the conductor, so it cancels above a certain frequency, it cancels out. It's a poor high-frequency conductor, essentially, and that's kind of the root of the first cables I did, and basically we still do the same thing to this day.
I'd say there are two fundamental issues that are easy to understand with electrical delivery to high-end electronics, which behave very differently than your standard household appliance, meaning they pull very hard just off the top and bottom of the sine wave, and this means that they're very sensitive to contact resistance. So anything you have in line, the ideal power line would be an unconnected line from your breaker to your component. And that's because anything that the electrical signal encounters on its way to the component power supply is going to impede the volume of peak current getting in front of the rectifiers in time for the same time that the component's asking it to be there. And the stock power cord that Cal showed you is completely inferior in terms of electrical delivery, even to a CD player, in terms of the CD player's power supply operating at peak efficiency. So anything you can do to minimize the contact resistance between the component and the wall, or even wall outlets, power cords, those industries are really all based on two fundamental precepts. One is instantaneous current delivery to the component and making a more efficient pathway for that. And secondarily is that component-to-component interference, or the radiated electromagnetic energies that surround electronic systems. So if you can mitigate contact resistance, and you don't have to spend a ton of money to do that, even getting rid of the stock power cords and having somebody competent solder a good connector onto the power cord, a watt gate or some other high-quality connector, and using a better gauge than exists in the stock power cords, because they're just crimped. They're not soldered. If you take off the mold on the end of a stock power cord, the wire just literally falls out. So there's very little connection there. And components need that. So if you focus on just eliminating that contact resistance between the component and even the panel, one thing I'll tell people, and maybe you can try this at home if you've lived in a house for more than, let's say, 10 years, and you haven't had an electrician out to fix anything in the home, and you've got to fix a light bulb or whatever, have them tighten the contacts at the panel, obviously shutting the panel off first, and have him tighten the contacts at the breaker that feeds your music system. Now often, they're just imperceptibly loose. It's not going to cause a danger, it's not going to cause any harm to the home or an electrical problem, but they do become loose over time because of that constant vibration that electrical panels encounter. 7 days a week, 24 hours a day, they're vibrating. And so those contacts can come slightly loose. And if you have them tighten that, listen before he does that, listen after, in probably 90% of the cases of people I've told that, they call me back and are just absolutely floored at the difference. And that's a perfect example of how sensitive electronic systems are to contact resistance. Just that little bit of a turn to tighten that contact can make a huge difference. So that's an important aspect.
I'd like to just make a comment about that to follow up. It does make a big difference, the quality of the breakers that you use. So if you have a choice, use a top-tier breaker and use number 10, spec number 10 instead of number 12. And if your system is on a breaker that's been tripped a few times, you might want to consider buying a new breaker, because it does damage the contacts if it's been tripped under load.
The carpenters.
Yep.
This is a question there that some people have when they come by and they listen to my system, and they say, well, you've got miles and miles of cable between the source that's generating the electricity. Why would changing the cable in the last 6 feet make any difference? And the way I've tried to explain this to them, and just correct me if I'm wrong, it's the reason why we use a reverse osmosis water filtration system underneath our sink for pure water, or another kind of a water filtration system. Is this a fair comparison to make for the different cables that you guys design and how they're used?
Yeah, that's true, but it's much more than that. Just that last 6 feet, there's a measurement device that exists, and just really electricians are the only ones that know about it, called an available short circuit current analyzer. And if you plug that into a wall, you can send a very instantaneous pulse through the wall, and you get a reading back that tells you what that line's rated at, how much current is available on that line, instantaneous current. And they do that because they're worried about any break in the line that exists that they might have to fix before they drywall. So it's a very important tool to commercial electricians. Well, in high-end parlance, if you pulse that, just say any line, you might come up with as much as 1.1 kiloamps of peak current. We have a video on our website that shows Kalen doing this test. And at our factory, I think it's 1.1 kiloamps of peak current, which is a ton of peak current available for a line. If you take a stock power cord and insert that between the wall and that available short circuit current analyzer, you're now down to 0.6 peak. So you've dropped almost 50% of the available peak current on that line with that last 6 feet. So that idea of miles and miles of wire is apropos, and yes, the noise, that water filter analogy does work in terms of the noise, but we believe, more importantly, you're dropping too much peak current energy between the wall and the component, and that's why there is a power cord industry in the most fundamental sense, is that loss that occurs.
When I purchase a new AC power cable, I'm often told by different dealers that this won't sound good for 100 hours or 200 hours or 400 hours. This idea of having burn-in time for an AC power cable, is this true? Does it need to burn in? And if it does, by rule of thumb, how long should this take? And what is it that's occurring in the cable that actually makes the cable sound better?
Let me just follow up on that. There is a device from a company called Amprobe. You can buy them for $337.16, called an Amprobe INSP3-3 wiring inspector tester. It's not quite to the level of what Grant's talking about, but it lets you really look at some wiring problems in your house, and it will let you look at the ampacity or instantaneous ampacity of a circuit without tripping the breaker. conductor, which is what you're doing. So for a few $100, you can get pretty darn close. Okay, so now to break in. During the manufacture of wires, extrusion process of the insulation over the cable and the drawing process of the strands, and then I'm thinking that there's another thing in there in between, because all wire, after it's manufactured, goes through a dielectric test. And it either goes through a charged liquid bath or through an ozone field where either DC is applied at really high potentials or high frequency is applied. And you will leave both mechanical stresses and strains during the manufacturing, and also an electret-like charge on the insulation. And so my theory, at least provisionally, is that as you use the cable, you tend to work those charges and those stresses out of the conductors and its associated insulation.
Cables need break-in. And I think our choices, we have a recipe in a sense when we're making a cable. Our choices to dielectric materials and dielectric thicknesses, and how many strands, how many different, what the geometry of our cables, and how many strands of insulated cables are being used through one conductor, through one pin. It requires the equalization process, or whatever that Ray's talking about, the relaxation process. And it may vary from a day or so with certain recipes to weeks and weeks with others. But it is real. You will find a change. I don't know that you'll find a metamorphosis, however. And I think some promise us a metamorphosis, and we don't see it that way with our own products. We see a subtle change, a maturation, if you will, a refinement, but not a metamorphosis.
Yeah, I think I found the same thing that Ray did years ago. It's called, with the arc fault testers were causing the problem initially. So we stopped using them. Was a good start. And it didn't entirely stop the problem, because what you're talking about is packeting. And particularly in a signal cable, that at certain points along the dielectric, you get higher and lower voltage. So it causes the equivalent of reflection or structural return loss. But it doesn't make any difference what you do in the manufacturing process, though, even if it came back without these stresses in it, and they are measurable, by the way, but even if it came out without the stresses in it, when you coil the cable up and put it in a bag and take it out and then stretch the thing back out, it will remake the lack of distribution, along the dielectric. So, but you can accelerate the process a little bit simply by playing the stereo. Sometimes a frequency sweep helps a lot, and we make a record that does that, and I know Air makes a disc that does it. But in the signal cables, it's evening out of these charges. In the speaker cables, the mechanical motion of the cable itself, it wants to settle down, into a certain form. So, people put little cups and things under them and all that kind of thing. And in part, that allows them to even out the mechanical stress, and that calms them down. I've actually had cables over the years that would generate an echo. Ones of prototypes and stuff that you could actually generate, like speaker cables, they had enough mechanical motion in them that you could hear an echo in them. But anyway, they got to settle in.
Okay.
I would just add that, a lot of the break-in, at least in cable, also has something to do with the terminations, how the cable's terminated, the type of solder that's being used, how whether it's cold soldering or another type of solder. There are also those junctions that the signal has to traverse, whether it be electrical or signal, that you have to create those pathways for the signal at the molecular level through the conductor, past the junction, corrosion, and any type of metals. I guess now there's a kind of a burn-in device industry too that promises better performance or quicker burn-in, and some of those devices are effective at increasing or decreasing the amount of time that you need to break in a cable, but you have to be careful with those too, because you can, I guess there's not a technical word I could use for it, but you can overburn a cable. So using them minimally can be beneficial. Using them too much can create the opposite effect, and so you've got to actually put it back in the system and wait the amount of time you would have had to wait anyway to just get it back to where it should be. So there's a lot of devices and even some burn-in discs on the market that can be effective, but you want to use caution and care with them and not overuse them.
Great.
So.
Several years ago, I went to an audio retailer, and I was looking for a power conditioner, and I was sold this one here, and the guy said that on the package it could be struck by lightning like 17 times and still protect my gear. And this didn't cost more than about $10, so I thought it was a good buy, so I bought it. You guys sell power conditioners for hundreds and sometimes thousands of dollars. What is it that your equipment is doing different than mine?
Well, we don't make power conditioners, and you wasted $10. And so no, I mean, if there is a need for a power conditioner, say you live in a rural area and you're at the end of very long lines, you will in fact need power factor correction to get the current and the voltage back in phase so that you're getting power that you can use. And if you've got noise on the line, you should address that. And I've used power conditioners, and usually it's either they make it sound worse, it's the same, or it makes it sound a lot better. And we could make some, but we have motorcycles to ride and pinball machines to play, and so we just haven't done it. There you go.
We also actually do not make a power conditioner. We make a power distribution box, but it just distributes the power. It doesn't filter it or... I would say with respect to that whole field, more and more power supplies within equipment, within the electronics we purchase, are being addressed. They're being designed at a higher and higher performance level all the time. I don't know that it mitigates the need for conditioning, under specific circumstances, but I think the need for it is probably reduced from the time period in which they first started to appear.
I don't make power conditioners, but I've played with them over the years, and I've had essentially the same findings that Ray has, and most other people. They tend to make things sound worse rather than better for the most part, although I've had things that helped on the mic pre's when it was real noisy and stuff. But in answer to your question, what we do that's different than the power conditioners is the way we address the ground leg. You see, all the power conditioners, typically they were a transformer, and they were just going into another transformer, so it was like silly. It was redundant. It really didn't do much except slow things down. But it's very demonstrable that addressing the issue on the ground leg and getting it equal to the other ones above a certain frequency makes a big difference, and you can do that with a power cord.
Okay. Grant.
A little bit of this is redundant, but briefly, power conditioning historically is created from a brick wall approach, meaning build a wall, prevent all the bad things that can get to your system from getting in from the grid and affecting your electronics. And there are many different types of brick walls that can be built: regeneration, transformers, chokes, coils, and as Ray and George attest, they're very variable depending on what you're plugging into them, how sensitive that component is to peak current, but more importantly, and this is just a little technical, in that they all have a reactive element of some kind, meaning they're either inductive or capacitive. And as Joe said, you've already got inductive and or capacitive elements in your power supply. So if you're putting anything in front of a collection of electronics, and sometimes the electronics are from different manufacturers and they're designed differently, and the power supplies are sensitive to peak current, as I mentioned, it's a dicey game to build a power conditioner that, number one, won't interfere with the component's ability to draw that peak current off the line that it needs, because you're adding contact resistance. And two, you don't want to interfere with the power conditioning that the manufacturer has already designed into the power supply. However, there's a problem that exists, two problems. One, most people have, what, 6, 7, 8 components, and well, where do you plug them? Do you use a power strip like Cal has there? No, because you've got the same problem. You've got huge contact resistance issues with that product, and really specious engineering that goes into that. So, and you want to isolate each component in the system from each other component in the system for obvious reasons, because the electronics are kicking back high-frequency noise onto the line. So as the component power supply is functioning to draw current in, the rectifiers are kicking back a lot of high-frequency noise, especially digital systems. So you want to build in some type of high-frequency noise sink into a power conditioner, and you want to make it not resist current on the way to components. And if you can do those two things without affecting what the manufacturer has in the power supply, then you've got a chance to effect a consistent difference and a consistent performance improvement in systems without adding a negative. But again, it's the end user that has to determine that, and fortunately you all have access to these things from dealers and should try them before you put good money down on them.
Yeah, follow up.
So at Kimber Cable, we've got a pair of interesting instruments made by a company called Yokogawa, and one of them is a power analyzer, $30,000-$40,000, and the other one actually will generate power itself, along with a whole host of interferences. So we can insert noise on a line, and it generates it. And so in between those two, we take a look at the power cords that we do, but we could also generate something that needs power factor correction or something like that, and then put it through it and then analyze it on the other end. But you're on the far end of $50,000 for that pair of instruments.
Great. When I was shopping for my power conditioner, I was also shopping for some speaker wire, and I got a monster of a cable here. And it looks pretty darn thick. That means it'll sound good, right? And on this end, they have these nifty little connectors, and it looks like they're made of gold. So, I bought these. I think I spent $199, and I got 2 of them, and they're about 10 feet long. What is it that your cable does differently or better than something like this? And briefly, why?
Well, I don't think that cable will cause your system to blow up. So in the sense that it does no harm, so far so good. The little pin connectors are simply another hurdle that the signal will need to jump to get from the amplifier to the speakers. And if you're using an older receiver, older electronics that has the button that you push and you put it in, those were actually designed for bare wire. You'll get a much better connection using untinned stranded wire in those than using a pin or tinning the wire, because solder is only a fraction of the conductivity of the copper, so tinning it, unless you've got an extraordinarily good reason to do it, shouldn't be done. Doug Sachs had a book, a very old book, and in the front of it, the foreword said, "There is no connector as good as no connector." And so if you do intermediate things just for the sake of doing it, there needs to be a good reason to do it, but otherwise, no. And I suspect that, did the sound thick with that with those cables?
It sounded thicker and it sounded faster.
Oh, okay, fine. Yep, okay.
I guess simply I could say that in our speaker cable design, we're trying to design for a low impedance and a high current capability. And we find that, in a sense, the more current capacity that we have in a speaker cable, the more it seems to couple the amplifier to the drivers and perform at a better level.
I'm not exactly sure the question, but...
what is it in your cables that when you make speaker cables?
Okay, I got distracted by the connectors. So we forge our connectors on, and it's all one piece of the same material. But cable to me is pretty straightforward. You're making a transmission line of one form or another, depending upon whether it's signal or speaker cable, and that noise is part of the equation, and Ray nailed that one in a way. And the more crosses you put in it, the better it gets. So there's various ways of doing that. But basically, if you have a stereo system and you are into it, you set it up completely symmetrical. You make the left side the same as the right side, and you're fanatic about it. You'll get it just right. And so you've got length and width, and you don't have to worry about time because the speed of sound is the same in both sides of the room. A speaker cable or an interconnect cable, as the case may be, is the same way. It's a stereo system. It's a stereo pair. Only one is a mirror image of the other. So, and you have two storage elements. You have capacitance and inductance. And so you have to match those in time and space, so to speak. But the problem is one side of the room's got a different speed limit than the other. That the conductor goes faster than the dielectric, so to speak. So, like in a video cable or something, they would match impedance to align the two elements. We don't have that luxury because in audio it's a rising impedance system. So the only way to get everything the same and balanced is to slow the conductor down to match the dielectric. So that's what we've done, and we've been doing it for years one way or another, and it allows things to come into time. It gives you the stage that was built into the original recording, rather than giving you something that's different, and it feels right emotionally, and so that's what we've always done.
What we do is a little bit different, but, I'm familiar with both Ray's and George's cables, and they're some of the finest cables made in the world, and some of the reasons for that is because of the length of time they've been doing it, and their ability to research and develop their technologies, the parts, the conductor geometries, and implement those, and then eventually get the price down to a reasonable level so you can actually afford to get those cables, put them into your system, and be pleasantly surprised at the value that they offer. That's a complex equation for a lot of manufacturers, and Shunyata is trying to do the same thing. We've developed kind of a hollow core conductor design that's made up of many small wires, because if you just had a hollow core conductor, obviously you couldn't bend the cable at all, but there's a lot of wires making up a hollow core conductor to reduce what we call skin effect. We also have that circuit I described that helps minimize dielectric absorption, so more of the signals, if you measure, put a square wave through a wire, you see the square wave go in perfect and come out with rounded ends at either side. We do these tests live at CES, where we have done them in the past, and there's a video on our site that shows Kalen doing that square wave test through wire. And the circuit essentially keeps that square wave more intact at the end of a wire amplifier than it would be had you not have that circuit protecting the absorption of the signal into the dielectric. But that's not to say that what we do is any better than what Ray or George or Joe does. I think that each company has a unique perspective, and if you're really curious about what each has to offer, it's important to consider and try those different products in your own system, because signal cable, I think more than electrical, is going to be somewhat customer system dependent in terms of what type of electronics you have and what you're looking for in sound. So speaker cables and interconnects are definitely a try before you buy, but I think you can't go wrong with any of the companies that are up here in terms of trying those different products.
With regard to the length of either the interconnects or the speaker wires, which one should be longer and which one should be shorter in your system to deliver a better quality sound? Should I put if I had monoblocks as an example, should I put my amplifier right next to my speaker so that I have a shorter run of speaker cable and a longer interconnect? Or should it be the other way around? Or does it make a difference?
Yes, it would make a difference, and it's highly system dependent. And part of the system is how your gear must be placed in a room, or how you would like it to be placed in the room for visual elements. And so, for instance, if you had a preamp that had a relatively high output impedance, you would probably want to have short interconnects and then do long speaker cables, because that would be much less willing to drive a long interconnect length, and you'd pick up more noise and lose more signal. But if you've got a preamp that has, say, 10 ohms output impedance, which is not the same as the load impedance, then that, and especially balanced, then that gives you an advantage for noise and to be able to drive a longer interconnect. And so you may want to use a longer interconnect and shorter speaker cables to preserve that on the other end. And might be a price ratio too, because interconnects might cost less per foot than the speaker cables. So it's really your listening room and your equipment dependent, and there would be some attributes to sort out.
I agree completely. I'll make a generalization that today probably most preamps are designed such that they can drive relatively longer lengths of interconnects effortlessly.
2 preamps might be an exception.
2 preamps might be an exception, yes. But generally speaking, it's changed from 20 or 25 years ago, when we really had to be careful about the load we were presenting to the output of a preamp. So I would say the general answer to the question is probably long interconnects are better than long speaker cables, but as Ray said, it is system dependent.
Yeah, most of the industry sets up this way, and you look at a lot of the rooms and whatnot, but I say that the thing that it's often overlooked, though, is the microphonic feedback in the system. So if you have something that has a spinning disc in it, then it behooves you to have a long interconnect from the preamp to the amp and get the spinning disc to the other end of the room. And that makes as much of improvement as the cable will. It's just simply an isolation thing.
Yeah, I would just add that, having done so many different trade shows and more, manufacturers are very sensitive to how they set up their systems for trade shows, because they're always looking for the best sound. And by far, what I've seen is the long interconnect and the shorter speaker cables in general. But I think Ray's right that it's going to vary from system to system too.
Mm-hmm. And then I'm sure that the other guys will agree with the research that we've done at Kimber Cable involving speaker cable lengths. Is there an optimal length? And we've discovered 2 things that are always the case. The first one is that if the speaker cable is long enough to actually reach between the amplifier terminals and the speaker terminals, it works a lot better than if it's too short. And the other one is that if the cable is a lot longer than that, it's highly beneficial to us.
Good. That's good.
And don't coil your speaker cable if it's too long.
if I had to bundle my cables to create less of a rat's nest, does it make any difference if I bundle them or put them together with, say, Velcro as opposed to a just a piece of wire connector?
Cable tie?
Cable tie?
The rat's nest may in fact be audibly superior to wrapping and bundling. For instance, our speaker cables, they will tolerate being coiled up because of the counter-rotating braid will tolerate that electrically a little better, so you're not going to build a secondary pickup coil. But the right length would be the thing, and if you need to make up some length, just do some little snakes in back of some gear, you know, you can tidy it up, but if you tied the cable tie too tight, you're probably going to put some little stresses in the insulation and leave some marks, like you don't want to fall asleep on certain bed covers because you wake up and you've got a little crosshatch or something. Anyway, it's clearly your turn.
Cal, were we talking about simply two long speaker cables, or were we talking about behind a rack?
Behind a rack.
Okay. So to my way of thinking, and I don't have scientific data to support this, but my ears would tell me that the randomness of the rat's nest might be preferable to the bundling of everything into a neat and tidy assembly.
But if you're OCD, tidying up the cable is going to make your system sound better.
Exactly.
Okay.
Yeah, I'm kind of with the rat's nest guys. You start tying things down, you're setting up stresses and whatnot. You can go ahead and make it look neat, but trying to really control it is not a good idea.
Okay.
And I would just add, if you really want to go OCD, and many people do, they spend that kind of money on their system, and they do care about trying to get that perfect sound, and cable routing does make a difference, and it is audible. So if possible, crossing cables at 90-degree angles, if they have to be touching, is a good idea. And if possible, even creating maybe a half-inch of space between cables is a good idea, just so those, and running them parallel, that's the worst idea of all, because then you've got too much interaction going on between the fields with two cables running in parallel.
I'd like to interject something here, that if the cable is made and it's properly crossed internally, if it's braided like Ray's or layered in crossing layers like mine and so on, these type of things they just don't have that much effect.
It's less important. And I was just going to add one more thing. So you've got right-left channels in many cases, and so if you're coming out of, say, a CD player and you're going to the preamp, don't come out of the preamp and then do it like this to get to the preamp. Just do it the same way, because otherwise what you're doing is you're setting up an inductive antennal loop by having the right channel one go down one side of the rack and the left channel one go down the other side of the rack. Run them generally together so that you don't set up that physical antenna loop.
Yeah, we found that in the extreme with phono cables, and actually have found that having both channels inside the same cable is measurably quieter.
Yes.
Just before we finish my questions, because I want to give the people in the audience an opportunity to ask a question. If I could only buy two cables, that's where I am money-wise, what cables should I upgrade first?
I've got this one.
Okay.
So the show of the hands at the first of the demonstration, if you could only tune two strings, which two would you tune?
Okay.
Okay, so, but, pardon?
And your choice?
No. I mean, if you played a guitar yeah, you could only choose two. And so.
With the bottom two.
Yeah, it's so system dependent, because, for instance, if you just put a new string on your instrument, that's going to stretch more as you play it. So you may want to make sure that one's tuned, depending on the music that you play on that instrument. And so it really really is system dependent. And you may want to rather than just do two, you may want to decide on one and buy a much better one, and then buy another one, so that you don't spread that out over a bunch of used cables. So it's both your sensibility financially and what your system might need first. You might, my sense of it is that if you had ordinary cables everywhere, that you may want to do an upgrade of the speaker cables first, along with power cords. But it's so system dependent that, meaning your system, that you'd have to really consider the pros and cons. And that's it.
Again, basically agree with everything there. Of course, your system, in terms of the quality of the cables that do exist in every position, might lead you to a particular cable that you know is underperforming. But generally speaking, speaker cable first. Interconnects, I would tend to work from the source to the amp, sort of in that order, source to pre to amp kind of thing. Power cables, I would probably, if I had to start buying power cables, I'd probably put it on my source first, my amps next, my preamp last, would be my guess.
Yeah, and I think that's well stated. I think that it depends a little, it's system dependent, it's also customer dependent. If the customer has a properly set up system, and they've gone to a lot of work, I mean, that's really important to get the room and the speaker and so on and so forth. If they have paid that much attention to the system and they haven't put anything into cables, all they've had is the free one out of the box and so on, then possibly the power cord might be the best way to go, but...
Yeah, I agree.
Yeah, I'm based on my experience in doing this 15 years, by far the electrical system itself, the electrical foundation, in my experience, is that word. It's foundational. Everything that you do after that is in terms of cabling, is, in my opinion, more about tuning, more about getting that kind of finding that right balance for the system. But if your electrical is out of balance and there's a problem with the electrical, finding that perfect balance elsewhere in the system is going to be more difficult. So I view power cords and power conditioning, whether you have it or don't have it, but figuring that equation out is probably most important.
I got permission to do a gratuitous plug. Russ Andrews from the UK is here, and for his demo, he bought off eBay after he got here about $600 worth of used gear. So $600 covered the source, the amp, and the speakers, and then he's got more than 100 times that amount in the cables, and he can demonstrate to you that reasonably good quality gear can still gain from having good cables. And so the 10% on the cable rule is not invalid, but certainly even modest gear can gain audibly from having extraordinary cables.
Do you know what room that is? What space?
It's just across the hall. It's between what's the clear speakers?
Perfect 8.
It's between Perfect 8 and Kimber Cable.
Okay, great. Is there a question from a member of the audience you'd like to ask?
You were talking mostly about power today, but I have a question concerning balance lines between components. It is Rough Carson of Atmosphere champions these balanced connections, and he says that if you do so, the difference between cables is greatly minimized, if not completely removed. And Ray, I know you make balance lines with pure copper, pure silver, and then a mix of copper and silver. There wasn't a difference balance-wise. I don't think you would do that.
let me repeat the question a little bit. So he's talking about if you have a balanced connection between components, does that not minimize the differences in cables? And it will minimize some aspects because you'll have an inherently lower noise floor, but the rest of the things like signal transfer from one end to the other, that's still going to be affected with the quality of the copper, the quality of the insulations, and the geometry. And so yes and no to your question.
I would say two things come to my mind. First of all, the preference for balanced or single-ended is very often equipment dependent on how those circuits are designed. But to my mind and to my experience, anytime we can lower a noise floor, we can appreciate differences greater. It's easier to differentiate.
Yeah, all of the above, but cables actually work better, in answer to your question, that in general, cables work better if they are balanced, and if it's done properly, even like a transformer, because the symmetry is very perfect one side to the other. So common mode rejection is one aspect, but you can turn that around, and the field that these cables create is also radiated, so which in turn becomes noise when it comes back on it. So I would say in general, if given that the balanced components are perfect, which is quite an expectation, that it is easier for cable to digest a balanced system.
Yeah, if electronics are truly balanced and you're testing cables that are XLR, that's how we set up our test jigs is using XLRs, because it's a superior connection and there's less variability between what you'd hear testing RCAs. So we use XLRs specifically because we can hear those differences a little better than testing RCAs.
Just as we're closing, because we're at the end of the hour, I apologize. Number one, I want to encourage all of you to visit the rooms that are just down the hall where these gentlemen have their products and where you can see them after the seminar. Speak to them after the seminar as well. And when you see the different rooms in this hotel and in the different rooms the dealers are using their product, ask the dealers how they feel about the product that they're using, and you might get even a more interesting or different perspective. So I want to give everyone here a thank you, applaud, and Ray's got one. Ray has a final question or a final statement he needs to add.
Yes, I would like to know, George, how would you describe a nun who's undergone a gender change operation? Why, that would be a transistor.
Thank you very much for coming.